Hi everyone, this is a video for lesson 6, which includes perpendicular bisector constructions as well as constructing a square inscribed inside of a circle. So we're going to start off by simply asking you, if someone asks you to construct the perpendicular bisector of a segment, what do you think that means? Um, and I think maybe of what that sentence says, there's really some familiar terms, but maybe altogether it doesn't really um, make much sense. So first, we're starting with a segment. So let's think, all right, someone tells me I have a segment and I need to construct the perpendicular bisector of that segment that I just created up here. So perpendicular bisector. So what am I going to do to that segment? And really the term perpendicular bisector, you break it apart, right? There's some meaning to it. So first, what does it mean to be perpendicular? So two lines that are perpendicular perhaps look something like this. Those are perpendicular lines. Two lines that look perpendicular could look something like this. Um, when lines are perpendicular, their main objective is to create 90-degree angles. So perpendicular lines create 90-degree angles. So up here, I'm going to construct something that's perpendicular to this segment here. So if this is a horizontal line, the perpendicular line that I construct has to be vertical. But we have to figure out where is it going to go through if it bisects or if it's a bisector of that segment. So now, if you bisect something, what have you done? And again, if you break apart the term bisect, right, you have bi and then sector. So bi is like a bicycle, right? Two. Sector, we're going to be cutting. So we're actually going to be creating two equal parts. So when you bisect something, you cut something into two equal parts. So what that means, if I'm going to construct the perpendicular bisector, I'm going to use my compass to hopefully create or construct a segment that is going to bisect the segment up here. And it's going to be perpendicular. Something that you want to take note of over here is the notation for perpendicular. The notation for perpendicular is this upside down T. So when you see this, it automatically means perpendicular. Now, I said this before, but it really is important to recognize that lines that are perpendicular don't always have to look like the T, right? So these lines, or these segments now that I'm drawing, are technically perpendicular, right? They form 90-degree angles where they intersect. They don't go right in the middle, they just cross and create 90-degree angles. Specifically, if we take a look a little bit further, if we had to kind of sketch the line that we think might be the perpendicular bisector of the segment, where would we sketch it based off of the fact that we know it should create 90-degree angles and cut it into two equal parts? So if we have to sketch a line, maybe I'm going to make a dotted line, and maybe it looks like if I do this and I put it here, and I ask you, what do you think? Does this look like it bisected the segment? And the answer is no. The reason being is this piece here is obviously much smaller than this piece here. So if I'm sketching it, I want to try to get it to be as close as possible. I think that looks pretty decent. Right? And now it appears that it bisected it because this piece and this piece appear to be pretty equal in length. So in order to construct the perpendicular bisector, we're not going to just sketch something. It's going to be very precise. We're going to use our compass and our straight edge. We actually can use the equilateral triangle construction to get the perpendicular bisector of any segment. So it says, using what we learned, construct an equilateral triangle whose length is RP on the given ray. All right, so let's start this. So we are going to copy RP to the given ray and then construct the equilateral triangle. So just to walk through some steps, first and foremost, I'm going to start with R. So I'm going to make this R prime. Sorry about the bell. And now I'm going to take my compass and I need to work to copy segment length RP on my ray. So go ahead, I'm going to go from R, open up to P. I'm going to change the color so you can see what I'm doing to blue. Show that I've measured it. Now to copy this length, I'm going to keep my compass width the same. Try to get to the middle of the point. And I don't like this. Is so there we go. And we're going to swing an arc through. Perfect. And this here I can label as P prime. All right. And here we have it. Now I have to get it to be an equilateral triangle. So you have to think back to 2 constructions ago and 2 lessons ago. So to get the equilateral triangle, I have to go up here. But actually, there's another option. I can also swing my arc down here. If you remember when we did the equilateral triangle, you can construct it either with the point up above the line or below the line. So I'm actually going to do it 2 ways now. Now to get my intersection points, I'm going to move the compass and here. And why not also go down here? All right. So at this point, I have 2 options. If I want to make my triangle, I can connect here to here or here to here. Or I can connect P prime to the arc on the bottom and then the arc on the bottom to R prime. And I really have 2 equilateral triangles, one above and one below. So now that we've created equilateral triangles, I guess the question is, how do you think I can take this construction and get the perpendicular bisector of R prime P prime? So how can I take my straight edge at this point and figure out where a perpendicular bisector should lie? And you might be saying, well, Miss M, there are only 2 spots right now that I can connect. The only 2 parts that I can connect, right here and right here. And if I connect these 2 arcs with, I'm going to make it a dotted line, with this dotted line, take a look at what happens. It goes through R prime P prime, what appears to be in the center, and it's also perpendicular. So we just created the perpendicular bisector of R prime P prime. So that means a whole lot. Since we've taken R prime P prime, we've just cut it in half. We've gone through the middle. We've created right angles, and we have constructed the perpendicular bisector. We are going to write these steps down, but just remember that what we actually used was the construction of an equilateral triangle, and the additional steps was to have arcs above and below. All right, so let's kind of right here. How did you create the perpendicular bisector of R prime P prime? You connected or connect the arcs, intersect below and above the segment with your straight edge. Enter. And there you have it. Okay, so next step is to talk about this perpendicular bisector of a segment in length. There are a lot of aspects of a perpendicular bisector. To talk about it, what I want you to do is actually construct the perpendicular bisector. So let's do that together. So to construct the perpendicular bisector, what we did before was construct an equilateral triangle. So we're going to measure from K to G, right? And I could show you measured by kind of putting my little arc here if I'd like. And then we said we're going to swing an arc above and below. It's like the equilateral triangle, and I'm going in both directions. Then we're going to flip the compass, keeping that width the same, not changing it. And we're going to go above, make that arc smaller, it just needs to intersect, and below. Okay? And now I'm going to take my straight edge, and you want to get into the habit of now going through the arcs. Don't stop at where the arcs are. Actually continue and make it a line. So I'm going to add arrows to both ends. And there we have it. So now this is the perpendicular bisector. Now, you might be thinking, do I have to go the entire distance from G to K in order to get the arcs to intersect and have a perpendicular bisector? And actually the answer is no. We're going to teach you, and I'm going to tell you right now, that all you have to be certain is that you go more than halfway. So take a look. I'm going to shorten up my compass to be right about there. And I'm going to keep this as my compass width. And I'm going to create my arcs above and below. Okay? I'm going to keep the width the same. I'm going to flip it. I'm going to move it to K, and I'm going to do the same thing. And what do you notice? The arcs intersect still on that line. So it would still create the perpendicular bisector. But let's take a look at what happens if I don't go more than halfway. They go really, really close, but not exactly halfway. Okay, I'm going to make an arc above and below. And before I go any further, do you think you know what's going to happen? Yeah, they're not going to intersect. Because when I go to G and I go to make my arcs, they're going to be all the way over here. I don't have an intersection. Without an intersection, I can't even create any sort of segment or point. So that's why you want to go more than halfway. Any distance more than halfway. If you go the full distance, it'll always be good. Okay, so now that we have the perpendicular bisector, let's label this point right here that we just created right here. I'm going to put a point here, and I'm going to call that point M. And I'm calling it point M for two purposes. One, this point is actually considered a midpoint, right? This perpendicular bisector cuts it in half into two equal pieces. So now M is actually the midpoint of segment KG. So off to the side under the first conclusion, we're going to put that in there. M is the midpoint of KG. Since I cut this in half, that's the middle. So if I have a midpoint, what does that mean? Well, if there's two equal parts, where are my equal parts? And my equal parts are between K and M, so this piece here, and then G to M. So I know that KM is equal to GM. When we talked about the equilateral triangle having equal segments or sides, we put a little dash mark. So I'm going to put like a line through it, a tick mark and a tick mark. And notice what I'm going to put over here now. KM equals GM. So endpoint to middle, endpoint to middle. This is going to be very important. When you name segments in math and you're talking about the relationship, such as they're equal, you have to say what is equal to what. So you're going to go endpoint to middle, and it should then be endpoint to middle. If I said Km is equal to Mg, it's not exactly accurate because K to M, I'm going from the end to the middle. So when I go from the end to the middle, it should be equal. And if two things are equal, they're also congruent. So this is the aspect of geometry where we have two worlds almost. Worlds in terms of measurement, which is equals, and worlds in terms of two things kind of matching up or aligning. And when we have that, we turn to actually calling something congruent. So if you make a copy on the copy machine, those two images are both equal and congruent. So if a segment is equal, it's also congruent. But notice as soon as you use congruence, you put the little squiggly on top, there's a bar that you put on top of KM and GM. So I like to think of it as when I put a little squiggle on top of my equal sign, I also have to put a little something on top of my letters. Okay, so that happens, right? We have two pieces now that are equal, KM and GM, those segments. And that was because of the bisector, right? So a bisector cuts something into two equal parts. Here are my equal parts right here. The midpoint that we said about conclusion 1, where is that midpoint, right? It's in the middle. So what does it do? It divides the segment into the two equal parts. So the bisector created the midpoint divided it into two equal parts. Okay, so now let's tackle perpendicular. So what does it mean for lines to be perpendicular? Well, simply put, perpendicular lines create or form right angles. So what do I know happened up here? Well, right angles were formed. So that's the conclusion. We're going to write that down. Right angles are formed. Now, where are the right angles? And we show that we have right angles by putting a little square or box into the angle. So where are the right angles? Well, right now we have right angles, and they are here, 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 and here. Those are your right angles. I can show that they're right angles by making tiny little box, and I put it right in here. You may have seen this in the past in maybe diagrams in algebra. This shows that I have a right angle. Now, if this is a right angle, I also know I have a right angle over here. I also have a right angle here and up here. So I really have 4 right angles. I'm not going to work to name the angles, although I'll show you how to name an angle quickly. I'm just going to name one of them. In order to name an angle, you need 3 letters, or you need to put a number in the angle. So I'm going to just put a letter up here. Okay. S. We'll call this S. So one right angle, I can say angle KMS is a right angle. And this, like, it looks like a less than symbol. That is actually a symbol for angle. So KMS is the right angle. Another right angle is over here. So if I wanted to name this angle, it would be GMS. That here. Angle GMS is a right angle. And we have 2 more down here, but I'm not going to really focus on that. I just wanted to have a little side note about what a right angle is and how we name it. Okay, so the 2 other conclusions are based off of the fact that we have a bisector. So how do I get KG? What 2 segments make up KG? And that would be this segment here and this segment here. So if I add KM and I attach to the end of M, MG, I'm left with this entire segment, which is called KG. So that's actually called addition, segment addition. KM plus MG equals KG. I think that's probably the easiest to think of right now, just adding the pieces together to get the whole segment. Now, if I take KM and I multiply it by 2, so KM and then I double it. Oh. Will Mr. Rand, Mr. Netwich, Mr. Hold on one second. And Ms. Milbury, please report to the large conference room in the high school, room 121A, please. Mr. Rand, Mr. Milbury, Mr. Sedman, and Mr. Netwich, can you please report to the large conference room in the high school, room 121A? Thank you. So if I take Km and I multiply it by 2, I also get Kg. Now, similarly, if I take Kg and I take half of it, I either end up with Km or Mg. So that's another statement that we can make. So based off of just constructing the perpendicular bisector, there are all these conclusions and relationships that are made. It's only the first day of it, so we're going to be kind of, working on this through the course of this unit. But you don't want to forget that just because you're doing constructions, algebra is involved, right? We can add segments to get a whole segment. We could take a half of a segment. We can double a segment. All of these relationships still hold true. So next part of this is actually getting down the steps in constructing the perpendicular bisector. So here they are. Step one is you need to take your compass and open it to the segment length. We talked about if you don't want to go the full distance, you have to make sure you just go more than halfway. So you have to go more than halfway. Going halfway is still not good enough. Then you're going to swing an arc above and below the segment. Now you need to flip your compass to the other endpoint, and then you repeat, swing an arc above and below. When you do this, after step 4, now you should have arcs that intersect. Put this here. Little arcs should intersect. Okay. And then finally, last step, you're going to connect where the arcs intersect. You're going to use this, use your straight edge and go through the intersection. Put arrows on the end of your line. And there it is. Okay. Again, remember this is your video, so you can pause, copy down the notes, listen, rewind. I'm going to, right here, create a segment quickly, and I'm going to show you exactly what we want, just to do it one more time. All right, and I come down here, take my compass, going to put on one endpoint. I'm going to open up just more than halfway, put an arc above. I always make my first arc pretty large, and below. Keep it the same, flip it, above, and below. Now take a look, I did this on purpose. You see how it just crosses? Very well, your first arc might be too small. You could always go back and you can make arcs longer. So if I had it to, I could have made this arc longer by going back, okay? And then finally, we said we want to take our straight edge and go through the intersection, right? You don't want to stop at the intersection. So we don't want to see this, right? I don't want to see that. What we'd like you to do is take your straight edge and actually start and go through the intersection and have arrows on both ends. Let me just put an arrow on the other end, and there it is. Okay. And from here, you can mark up a whole lot. You can put in your midpoint. You could show the pieces are equal. You could add right angles. There's a lot that you can do. Okay, so that's the perpendicular bisector. Now, the second part of our lesson is going to use the perpendicular bisector to construct a square. So we're going to construct a square, and it's actually going to be inscribed inside of a circle. So we're going to start like we did with the hexagon and like we did with the triangle, equilateral triangle. We're going to start with a circle. So put your point. You absolutely need your point, and now more than ever, you're going to see why. So you have your center point, take your compass, and create a decent sized circle. Okay, first step done. Next step, you have to draw in the diameter of the circle. So if you didn't have your center, you wouldn't be able to draw in your diameter. Because remember, the diameter goes from one end of the circle through the center to the other. Your diameter could be horizontal, vertical, diagonal. It's up to you. I'm going to keep it simple, and I'm just going to make my diameter go left to right and be horizontal. And I'm going to make this line a little bit thinner so you can see that it actually goes through the center. There it is. Okay, so once you have the diameter, it's just helpful to put a point on each end, a point and a point. Those are the two vertices of your square already. Remember, a square is 4 sides. It has 4 vertices. So now you have a segment, and you're going to construct the perpendicular bisector of the diameter. I'm going to take my compass, I'm going to one end point. I have to go more than halfway. So I'm going to go all the way here. And now I'm going to do the perpendicular bisector. Now, before you do anything, your arcs might be inside the circle, outside the circle, or on the circle. Any three of those scenarios is okay as long as it's past or more than halfway. So let's see where mine end up. Mine end up outside the circle. Okay, so I'm going to go above, and then I do need to go below because that's how we do the perpendicular bisector, making my first arc rather big. Okay, and now I'm going to flip it, and I'm going to go to the other endpoint, go above and below. All right, and now I need the perpendicular bisector, so I'm going to connect through the intersection. Make sure you go through, especially if your arcs are inside the circle. You have to make sure that you get the perpendicular bisector that crosses the circle itself. Let's go over just a tad. All right, and here we are. All right, now you don't have a square. You just have 2 lines. We're going to take our pencil or pen, and we're going to make 2 more points. Where the line, the perpendicular bisector, crosses the circle, you're going to put 2 more points. Now we have 1, 2, 3, 4 points, and we're going to connect them using our straight edge. So we're going to connect from the diameter to that 1 point, other diameter point, and then to the point below the diameter. And there you have your square. If you happen to, I'm going to do this again kind of quickly, so you can just see. If you maybe did it this way, put a point, and bring our circle. Just want to show you the difference. Okay, so my circle, I'm going to get in my diameter. Okay, and now I'm just going to make this thinner. Okay, so if you chose possibly a length that was maybe like this, still a good length, right, because it's past halfway, but your arcs perhaps were like this. And I have to flip it, go to the other endpoint, keeping it the same. Still okay. This is the main reason why we say now that you have to go through your arcs. Because if I were to go from here to here, it never touches the circle. I don't know how to make my square. So you have to make sure that you're going to go through the circle, through the arc. And now you have your additional points. You should put your arrows on the end of this. Perfect. And now we can make our square because we have our 4 points. We have 1, 2, 3, 4. Remember, it's inscribed because the vertices are actually on the circle itself. Done. Okay. And there you have how to construct a square inscribed in a circle using the perpendicular bisector. On the next page, here are the steps. So you constructed yourself a circle. Make sure, I'm going to kind of put here, must start with the center point. Then you draw in your diameter. You put the endpoints or put the points on the end of the diameter. You use the endpoints to construct the perpendicular bisector. Connect the two endpoints and the two intersections of the perpendicular bisector, and you've created yourself a square. Okay, so this lesson we talked about not only the term perpendicular bisector and what it means, but how to construct the perpendicular bisector of a segment and how to then use that construction to construct a square. One thing that I do want to go over before I kind of finish up is that if you have a line versus a segment, and we asked you to construct the perpendicular bisector of a line, you cannot construct the perpendicular bisector of a line. As soon as there's arrows, you don't have a middle point. They go on infinitely in both directions. You can, however, construct the perpendicular bisector of a segment because it's a given distance. So that's something you just want to keep in mind. You cannot construct perpendicular bisector of a line because a line goes on forever. Therefore, there is no middle. Okay, just keep that in mind. That's going to be a big common theme throughout talking about a perpendicular bisector. But that finishes up the lesson. So please make sure that you submit the practice to lesson 6 by taking a picture of your work on a separate sheet of paper. And should you have any questions, please just reach out to us through the Google Classroom or email.